Hello, welcome to Op-Amps Level 2. Right, we have a circuit of minus 0.419. It's minus, so we know we're going to need to build an inverting amplifier. Now an inverting amplifier has the input going into the inverting input, which is the one with the minus sign here, and it has a gain given by the feedback resistor. That's this resistor here divided by that resistor here. So we need the ratio of that resistor to be 0.419. Easiest way to do that is to make that one a 409 ohm resistor. We also have to attach the non-inverting input to ground, and it doesn't matter really what resistance that one is. It's not going to affect the gain of an ideal op-amp. It's not particularly tidy, but it'll do. Gets me the points. Next one. Right, unknown resistor value. Here we have a inverting amplifier, and this you'll notice is upside down. The positive is the longer terminal, so the voltage here would be minus 5.3 volts, and the voltage at the output is 1.8. So the gain of this amplifier would be 1.8 divided by minus 5.3 or minus 0.339, etc. And that has to be equal to this resistor divided by that resistor times minus 1. In other words, that resistor divided by this resistor is 0.3396 and so on, which means the unknown resistor must be 15k times 0.339623, etc. Fine. Next. This time we want a circuit with a positive gain, so we need to build a non-inverting amplifier. A non-inverting amplifier would have the input here going into the plus terminal. If I double click on these, they swap over, by the way. Might make it easier to draw. There. And I need a resistor there and another one from here, and that resistor goes to ground. That resistor I don't need. Output comes from there. Okay, that's the standard form of a non-inverting amplifier. Now, the gain of a non-inverting amplifier is 1 plus the ratio of these two resistors. So the ratio of these two resistors must be just 0.48, and the easiest way to do that is to make that one 480. Because then I would have here a 480 divided by 1k, and the gain of that circuit would then be 1 plus 480 divided by 1k, in other words 1.48. Don't need to use that resistor at all. I could use it, I could put it in here, it would make no difference. The unknown resistor value here is going to be, let's see, what gain does this have? Well, it has an input of minus 19 volts and an output of 4.6. So the total gain of this circuit would be 4.6 divided by minus 19, or minus 0.242. And for an inverting amplifier like this, the gain is minus the feedback resistor, in our case 1k5, divided by the input resistor, which in our case we don't know. And we know this gain is equal to the output divided by the input, which we've just worked out to be minus 0.242. Should be accurate enough. Equals 1k5 divided by the unknown. The minus signs cancel. That tells me that the unknown resistor is 1k5 divided by 0.242. In other words, divided by 0.242, and so on. There's one other type of question that you might get at level 2, and that's this one. It's a summing amplifier. And the rule for a summing amplifier is that the output, Vout, is equal the sum of the input here, which would be minus 0.4, minus 0.4 because this is upside down. The positive terminal is at the bottom connected to ground, so that point there will be at 400 millivolts below ground, in other words minus 0.4 volts, times the gain from here to the output, which, since this is an inverting amplifier, would be minus the feedback resistor, 390, divided by the input resistor, 1K3. And then plus the contribution from the other input here. Well, that there would be minus 1.3 volts, again minus because this has its positive terminal connected to ground. That would be minus 1.3 times, again, minus the feedback resistor, 390, divided by the input resistor, which we don't know. And we know the output is 938 millivolts. So, this is the sum that we're going to try and do, where V out is 938 millivolts. Well, those two minus signs will cancel with each other, and so will these, giving me a plus on this point here. So I could write that as 0.4 times 390 divided by 1K3 plus 1.3 times 390 divided by the resistor that I don't know yet. Bit of algebra on that would give me 1.3 times 390 divided by the unknown equals 0.938 minus 0.4 times 390 over 1K3. In other words, the unknown resistor will be 1.3 times 390 divided by that lot, 0.938 minus 0.4 times 390 divided by 1K3. Right, I'll need to be a bit careful with brackets when I enter that lot, but let's give it a go. It's 1.3 times 390 divided by, open brackets, 0.938 minus 0.4 times 390 divided by 1K3. Right, excellent. Not so bad really. Hopefully that will get you started.